Okay, let's get started. PS6 is due. I made it due tomorrow. Make sure this is going. Or Saturday for late date. Are there any questions or problems about that or anything else? Is PS6 going okay? Okay, so I just want to, one thing I want to tell you about is, I've had a lot of questions about validators and normalizers and such. But basically, the normalizer that you need to use is one that capitalizes every letter in a variable name. And the validator needs to make sure that there's no, well, the validator is provided in the constructor, so you don't have to worry about that. But the whole thing is designed so that if you need to, if you want to put a formula in uppercase and make sure all the variables it contains are valid, you just pass the validator and the normalizer to the formula constructor and let it do it for you. So if you find yourself getting the variables out of a formula and validating them in the spreadsheet class, you're going about the wrong way. Just that's why we added those things in PS4. Okay. Okay, so tomorrow I will release PS7, and it'll be due in 2 weeks, and we'll have the midterm next week. When we get back, when we're finished with the midterm week, because we'll review next Tuesday and have the exam on Thursday, we'll be starting some new stuff. Actually, we'll start some new stuff today, and a new project that you'll be working with a partner. And the project will involve using a RESTful server. REST is something we'll talk about today. So you'll be writing a client to access a server, and eventually you'll be writing the server as well. So we're going to start today learning what's involved in doing that. So the first thing I want to talk about, as you can see here, is HTTP. Except I'm in the wrong place. All right, so HTTP is short for Hypertext Transfer Protocol. And when you when you read about how the web was invented in 1992 or whatever, what was invented was, among other things, was HTTP, the Hypertext Transfer Protocol. It was a convenient way for to set up a server to serve documents to clients. So you all use HTTP every day when you use a web browser, and you should be familiar with it. I mean, it's what happens when you type in a URL or you fill in a form and submit it. What's happening is an HTTP request is going out from your client, your browser, to a server, and the server looks at the request and sends back what was requested. So, for example, you might just ask for a web page, a static web page, and the server sends you back the web page. So the request is made in an HTTP request, and the response comes back in an HTTP response. And protocol just refers to the rules and how you format the request. What's the text that you send over the web look like? What's the stuff that comes back look like? Another common use case is you submit a form. So basically, when you submit a form, you're asking the server to run a program for you, and you're providing the parameters. So the values you enter into the form are the parameters, and you're essentially asking the server to run that program, and the response contains, it's run the program, and it's giving you back whatever it wants you to see as a result. Maybe it tells you you've made your plane reservation, or you've ordered something from Amazon, it'll be shipped. We're interested in web services. So in addition to having websites that respond, that's intended to be interacted with via browsers, there are lots of places that provide web services. And these are servers. They're just as much are HTTP servers, just like your familiar websites, except they're designed to communicate with programs, not with people using a browser. So they're designed for what you're going to be doing, which is writing a client that is going to communicate with the server. So it's the program that's doing it, not the web browser. So what we're going to think about today is web services. Yeah?
It says hypertext. What is hypertext? Is hypertext referred to whatever kind of document, or what is hypertext?
Right. Okay. So the HT and HTML is hypertext. Hypertext was originally it was text with images and links that you could click and go to see other pages. It's really the links that are the hypertext part. That was revolutionary at one time. All right, so this is a bit of the HTTP protocol, and it's called a GET request. And this is the simplest kind of request, and it's the type of thing that the kind of URL you might type directly into a browser. So, you see it on the top line up there. And, when we talk about these things, the protocol is HTTP right there. So that's the rules. We're saying I'm communicating via the rules of HTTP, but you see other things there. You see HTTPS, often, which is a secure form of HTTP. And there are other protocols you could put there. Then there's the domain, which is basically the web address of a server somewhere. Then after the domain comes the path up to the question mark. And that's information you're sending to the server. And sometimes you'll see a question mark, and after the question mark there'll be a series of key value pairs. In this case, ID equals 43 is the key value pair. Anyway, whatever you call this stuff, it's all sent to the server, and the server takes it apart and decides what to do with it. Now, when you type that into the browser, what's actually sent is looks a little bit different. It consists of a line that says I'm making a GET request, and that line also contains the path and the query information. Also along with an HTTP request goes headers. So a header are just key value pairs. So the body of the request is going to contain, or the header part of the request is going to contain key value pairs like this. So what's user agent? What's that look like? Yeah? Right, that identifies what kind of browser issued the request. Host, that's just sort of a repeat of what the domain is up there. This has to do with keeping the underlying network connection alive after the response is sent. This says what our preferred language is to see the response in. This says you can compress the content before you send it back, that's okay. And you're willing to get back HTML or XHTML. So request headers are the browser's way of sending information preferences to the server. Browser telling the server about itself. And then there's the final bit, following all the headers, there's a request body. In this case of this GET request, it's empty. And here's a POST request. So a POST request, the URL looks the same. The method is POST. And you've got no easy way of telling when you click a button, is the browser making a GET request for you or a POST request for you? But they work out a little bit differently. Most often when you submit a form, you're making a POST request. It has headers, just like the GET request, but it has a non-empty body. And what that body contains are the parameters that you're trying to send along with the POST request. So basically the values that you filled in the form with. Okay? Here's a typical HTTP response. So this is what your browser sees after you make, say, a GET request or a POST request. There's a first line that says status code 200. So you know some of the status codes. There are lots of status codes. 3-digit number. 200 means okay. 404 means there was didn't find the server, and so on. Then you see a bunch of headers that tells the browser something about the server. date, time, something about how it was transferred and so forth. Your server makes sense of, your browser makes sense of all that. And finally, there's a body, and the body contains the actual HTML, in this case, that the browser is supposed to display. So you've got requests and responses going back and forth. Now, we're not so interested in writing a web browser. We're interested in using web services. So when I have a program that wants to communicate with a server and get information back, I don't want to see it, my program doesn't want to see it, rather, formatted as HTML. HTML is designed for people to look at. It's got all kinds of features that are designed to make it easy for people to digest information. We're going to get our information back in a different way. And so the way that's done when we use a web service is we make a request to the server, and what comes back in the response is not typically HTML. It's nowadays, it's very often in JSON. So back here, if we were contacting a web service, our body would be JSON rather than HTML. If we're making a request of a web service and it's got to send us back a list of objects where each object has a bunch of properties, like a list of possible flights or a list of books by an author, that has to be formatted somehow. It has to be organized into some text form so it can be sent. So at one time, people used XML for that purpose. So, we saw how XML could be used to structure hierarchical data. So you could, we saw, for example, using XML to talk about the states and their capitals. And that was one way that information was formatted for transmission between programs, was use XML. JSON is just another way of doing it that's become much more common today. Conceptually, the way JSON works is, JSON stands for JavaScript Object Notation. So it sounds kind of weird to be using JavaScript object notation in a C# program. But conceptually what happens is you take a C# value, like an object or a list of objects or a string or an integer or whatever, you convert it to the corresponding JavaScript value. So basically, if you have an array of integers, you turn it into a JavaScript array of integers. Then you use the JavaScript toString method to convert it to a string. And that string is what you send, is what's sent as the JSON response to a request. And then on the other end, to decode the string, JavaScript has an eval method that will turn the string form of an object into an actual object. So we do that, and then we convert it from JavaScript to the corresponding C# value. In reality, that's not what happens at all. In reality, there's just a library that'll take a C# object and convert it to JSON. So the fact that JSON has its roots in JavaScript are just totally irrelevant when you're using C#. That's just historical information of why we call it JSON. So you can think of JSON just a convenient way to encode an object. So you can encode into JSON objects or structs or strings or arrays or primitives. One thing that confuses students at first, if you think of an object as data and methods, that's not what gets encoded. What gets encoded are the properties, if you will. So if you have a person that has a name property, an age property, a height property, then what gets encoded is that, not the methods that go along with it. So you just have to make sure that the program you're corresponding with views the data in the same way you do, because it'll be accessing it with a completely different program. All right, so that's JSON. So let's look at some examples of JSON. Okay, so there's a C# value 2, the integer 2. It gets encoded just as an integer. The string hello, strings encoded as strings, so there's really no transformation done there. Here's a person with 2 properties, name and age. That's what it looks like in JSON. So the property name, colon, and the value, which in this case is a string. The property age, colon, and the value, which is an int. So that's the encoding, and there's a C# array, there's a JSON array. So that stuff is just sort of the string form that gets sent across. All right, so let me stop and see if there are any questions so far about, we've talked about HTTP with its roots in communicating between web servers and web browsers. It's been repurposed, the whole protocol has been repurposed so that we can communicate from programs to servers. And since the server may be running who knows what language and we're running C#, we've got to have some way to send information back and forth. And we just settled on JSON as being the common notation we're going to use to send data back and forth. Yeah?
2 questions. Post and get were both capitalized. Is there a reason for that? Are they acronyms or something like that?
No, they're not acronyms. They're just capitalized.
Okay. And then where, like, is the person information stored anywhere? Or
What person information?
person P is equal to new person? Like,
Yeah. Well, this creates an object with a name field and an age field, age property.
right, does it have like a header anywhere in the JSON that would say this is a person?
Nope. That's what I'm saying. Oh, I see. Then the word person is not over here.
Exactly. How would it
Right.
know it's a person? If you're
It-
setting a
yeah,
person and a
that's-
dog and
Right. That's a great question. And the answer is the program just have to agree on what the data means. So let's say that the server is expecting you to send a person object as a parameter, and that person object must contain a name and an age property. So the way you would create that to send it to a remote server is just create an object like this and convert it to JSON. But there's no type information. There's nothing that stops the program. We're thinking of it as a person, and they interpret that in a completely different way.
does that mean like they requested a person and then you send back a person so they know it's a person?
Yeah, well, so a web service has an API
Okay.
that says what kind of request you can make,
Right.
and it says what kind of data it expects as parameters, and it'll give examples. It'll say, I expect to see a JSON object that has a name and an age field, and I'm going to interpret that as a person, and it's your problem to get the data there. But there's no type checking like there is in C#. It's just whatever goes, goes. Anything else? Yeah.
How does the HTTP data actually get sent to the server? Is it like just opening a TCP connection or a telnet or something like that?
Yeah, so it depends what level of, he's asking how does the information get there. Depends what level of networking you want to talk about, but yeah, it opens a TCP connection, it opens a socket. We're not worried about that level of detail, but yeah, it uses the low level of the network to send text across. Yeah.
When you say it sends text across, is it send some kind of file or anything like that?
No, what happens is the connection is opened, and then a series of characters are sent. And the first character, if it's a request, the first line is formatted. It'll say get. It'll have the URL. The next few lines will have those headers like I showed you. Then there'll be a blank line. Then there'll be the text of the body if there is a body. And that's just so it's not I don't really think of it as a document. You're just sending characters across, and then there's the end, and then it reads what it got and made sense of it. Anything else? Okay. Now, there are lots of web services out there, and they have been for a long time. But nowadays, the most common way to organize a web service is as what's called a RESTful API. And RESTful APIs tend to be JSON-based, but they don't have to be. For example, GitHub provides an API that lets you write tools to manipulate GitHub. So for example, at the beginning of the semester, when you had to, when we were getting GitHub set up, so you all belonged to my organization, you use a little web application that I wrote. And what that web application did was, when you used it, it used the GitHub API to go and add you to my organization. It also, I believe, well, certainly what you're going to be doing is setting up pairs. You'll be working in pairs. And so I'll give you another application you'll use. You'll enter your UID, your partner's UID. It'll use the Canvas API to set you up as a Canvas group. So you're graded as one, you submit as one. It'll use the GitHub API to set up stuff on GitHub. So I use both of these extensively. I've written a lot of scripts, a lot of programs that run against the Canvas API, because there'll be things Canvas won't do for me via the normal interface that I can do via the API. So it really opens up a big world when you learn how to use RESTful APIs, like we're going to see here. Suddenly, you could write, if you wish to, you could start writing scripts against GitHub. Create your own Git client if you wanted to. The way you think about a service like this is you think of the service as maintaining a collection of resources. So GitHub, keeps track of users and organizations and repos and teams and files and commits and so forth. Canvas keeps track of assignments and submissions and grades and students and so on. And to use a remote API, you have to name a resource. And typically, you name the resource, the URL, the path portion of the URL names a resource you want to modify. So like in the case of GitHub, it would contain like the actual name of a repo would show up in the URL. Then you give an action to perform on that resource. A get, action, a post, a put, delete. We'll look at the differences, but you're basically saying what action to perform. You provide parameters either in the URL itself or encoded in JSON and in the body of the request. And then you receive a response containing a result, encoded in JSON typically. And we're going to look at examples to make this more concrete. But fundamentally, that's how it all works. Okay, here's an example. This first URL up here is to ask GitHub to give me information about all the commits on the master branch of a repo. So it's a GET request. And in yellow, you can see the URL. I'm saying I want the repo Joseph. No, I guess the URL, there's repos, and then Joseph must be a made-up username I made. The name of the repo is my repo, and I want the commits. And then I have an extra parameter there in the URL that says I want the master branch. So if you issue that, if you went and typed that into a web browser, except for the problem of authentication, back would come a JSON encoded array with information about each commit. Now in reality, if you typed it into a web browser, it would tell you you're denied access because you have to authenticate. Just not anyone can go ask about any repo. Although it is a public repo, so maybe if it's public, maybe authentication wouldn't be required. I don't remember right now. So anyway, you use GET request to get information back, not to change it. The PUT request is to change existing information. So here I'm saying go to this repo and add a new file called file.txt. And the actual contents of the file are contained in the body. And what you get back is something that describes the new commit that was created. So these are, when you use, say, the GET plugin in Visual Studio, it's these kinds of things are being sent on your behalf to GitHub. Now, what I want to do now is actually show you this stuff in action. So I'm going to get out of Google Slides here and drop into something called the Advanced REST Client. So the Advanced REST Client, it used to be a plug-in into the Chrome browser. I think it's standalone now, but it's a free thing you can download. And what it lets you do, let's see if I can make that a little bit bigger. It lets you experiment with remote services. So got these saved. I don't want to mess them up. I'm going to create a new tab here, over here. So I'm going to, you can just come here and let's say http://www.cs.utah.edu. So we could issue a GET request to that website. I'm not providing any headers. See, down here is where I would give headers, and I'm not defining any. I send it, and it shows what your browser sees. Now you can see this in your browser as well if you go, use the developer tools in your browser. But we got a 200 back, which meant the request was dealt with okay. And actually, I want to show me the parameters. Help me find, I want to see the response headers that came back. I'm not seeing where to click. Huh. Oh well. There are the response headers. So that's the actual raw response right there. Those are the headers that we got back. So we got back a date header, a server header, a link header, and whatever all those things mean. Then we got a blank line, and then we had all this. So the been a while since I used it. Okay, so that's the information your browser gets back. What it does is extract this stuff, which is the HTML, and display it for you.
Did Google make this? The RESTful client?
I don't know. It's a Chrome plugin, but I don't know if that means Google made it. And I click here on this little eyeball, and it'll actually show me what the HTML looks like. Okay, so I just picked a random website and typed it in. Now I could go, I don't have to look at our own website. I can go look at google.com and see what happens. And I guess I need to click send. Okay, and it said okay. And back came 12 response headers. And here's the actual body. So that's that. I mean, the Google homepage is very simple, but that's all JavaScript, obfuscated JavaScript. I'm sure they know what they're doing, but it's hard to it's hard to look at it and figure out what, if we look at it, it's just that. So anyway, it makes it possible to play around with websites if you want to. Now we want to pretend like we're a web service. So I have a URL here. This is using the GitHub API. So you can see my request up there. It says https://api.github.com/users. And I'm going to take off that since 1234. That's not really relevant here. So that's a request, which when I send it, will send me back information about every user on GitHub. Now let's see what else I'm sending. I'm sending also, along with the GET request, I'm sending these three headers: accept, authorization, and user agent. Now, typically, when a browser would send information about it. So what do you make of the information that I'm providing in these headers? So it's going to be sent. In addition to the URL, which is it's the plain old GET request, I'm sending these three headers. What is that telling the service? Yeah.
To be specific about what to return.
Okay, this says, yes, this says what I want back is JSON. So it's expecting me to tell me what it wants back. I'm not sure what happens if you tell it you want something else, because the API for the service said put that. Okay? What's this about? User agent typically identifies the browser. But the API just said, for user agent, include some identifying information. So I'm just following directions. What about this?
It requires like some sort of
The token.
That is the authentication part. So the authorization header, you're supposed to put the token followed by your authentication, your authorization token. So you can go into, I think I've got it up here. You can go into GitHub, and you go over here and you go to Settings, and then you come down here to Applications, and then, no, it's Developer Settings, I'm sorry, and you go to Personal Access Tokens, and you can see that before class, I created a token that I called CS3500 Lecture Token that gives me certain kinds of accesses. And so basically I logged into GitHub, I said, give me a token that will allow the bearer of the token to do these things. Delete repos, look at administrative stuff. And the token was yay long, and I copied it and pasted it into my program. So anyone that has that token could pose as me. Now, you might think it's a dangerous thing to do, to put my token on YouTube, or to show it to all of you. And it is, except it's sort of a dummy account. It's not my real one. So and I'm gonna delete the token after class. So there's not a whole lot you can do, because I don't care about the account. So having that, once the API just said to do that, and once I put it in here, now it will behave as it knows that I made the request. Anything I'm authorized to do, this program can do. So we issue the request. I don't know if I issued it. Let me issue it here. We get back the OK, and what you're seeing down here is JSON. So it's in particular, it's not raw JSON. It's formatted a little bit. Let me go to raw form. Okay, there's the raw JSON. So you can see it's an array of objects. I didn't mean to do that. So it's an array of objects, but it runs off the end. You know, it's a long array of objects. And I'll go out of raw mode. It'll format it for me a little. It says there's 30 elements in the array, and the first one is this object right here. I get back login name, the ID. So user 1 on GitHub is called Mojambo, and you got a link to the user's avatar, their URL, and so on. So we've got information about the first 30 users in their list of users. Okay? So I just, you can make that request in a program just like I made it here and get those back. Now if we look at the headers, you will see somewhere in here is a link header. And so this header right there tells me how to get more. So there's certainly thousands and thousands of GitHub users. It didn't want to serve me back the whole page, so it gave me back some, and it gave me a link for getting the rest. So if I copy that and go paste it back up in here again, well, you can see I've already done something similar, but I'll paste the link. I'll paste the link I just got. Need to take the angle brackets off. Now it's saying, give me the next batch starting with number 46. So I send that, and it sends me back 30 more. Okay. Starting with user J. Newland. So what the REST client lets you do is play around with the kinds of requests you want your program to make. So this is where you come to understand the API, learn how to make requests. And then it's just a matter, once you get it working here, you can copy and paste things into your program and have it run from there. We'll look at both sides of it. All right, let's look at a different one. Okay, this one says list all commits on a repo. And so you can see, let's see what it's saying. /repos. So think of everything after the github.com as sort of being a program to run and the parameters to run it on. So we're saying I want to find out repos, and it's in this organization, and there's the name of the repo, and I want information about the commits. And I'm not sure what that means. But anyway, I've got the same headers, I send it, and back comes information about all the commits that have been made on my spreadsheet repo. And we could look through them. Now, you may be wondering, how do you know what does it mean there's an API? So let's go see if I can find the GitHub API. There it is. And got all this information. Now, I made it, I can't find anything now, so. That's sort of, okay, over here, let's look at organizations. List your organizations. Okay, so now I can zoom in. So it's saying, if you want to list your organizations you issue, there's your thing. You use a get command, user /orgs, and it tells you the response will look like that. It gives you an example of what the response will look like. The response will be an array. The array will be of objects. Each object will have these properties. And so you can just dig through the API and find out how what services are provided, what type of request you have to make, get, post, put, delete, what have you, what the URL is supposed to look like, how you provide parameters to it. You can go to GitHub and you can go to the advanced REST client and play around with it. Make sure you understand it, then embed it in your program. So let's take a break and we'll look at a few more examples of this. Okay. So we just looked, this is the GitHub API, and we could look how to do other things. List all organizations, that's an easy GET request. All these are GETs. I haven't shown you a post yet, or a put, which are ways of changing things. Here's edit organization. Oh, I love this. This API may change without advance notice. So so far it hasn't changed underneath me, but I am worried. There's also a Canvas API that lets you do things like anything. So, I don't know, enrollments. So you can see here it says you can do things like enroll a user. So I click on enroll a user, it says enroll a user, you issue a post request, that's the URL you use, and these parameters have to be included in the body of the request. So enrollment, user ID, type, and so on. So it's telling you what you're supposed to include, gives you an example of what it looks like, and that's how the API is. It just shows you what you can do, it gives you an example of how to do it, and then you can go after it. Okay, so back to the advanced REST client. So we listed all my users and all my organizations, all my commits, I guess. So let's look at a post. So this is to create a new public repo. So you can see I have /user/repos, and the method is post. And let's see what I'm providing. I have got my header name, my accept, rather, my authorization, and my user agent are the same as before. But there's a new one, content type. And what's different with a post from a GET is with a post, there's going to be extra information going in the body of the request. So in addition to the URL going, which goes with a GET request, and the headers, which go with all requests, there's information elsewhere in the request. And that information is going to be in the form of JSON, is what this is saying right here. So let's go down here and look. That's where I ran it, so I need to look at the body. So those are the headers. Here's the body. I'll try to make this bigger. Okay? So that there is the body of the request. So down, the stuff we're sending to the server, it contains somewhere this very text. And you can see, what is that? What kind of JSON entity is that you're looking at? Is it an array? Is it an int? Is it a string? It's an object. It's an object with these two properties, name and description. So I'm saying I want you to create a repo called demo repo, and I want you to include this as its description. Yeah?
If you pass a JSON that has all the parameters plus extra, does it just ignore all the extra?
Okay, fair question. What happens if we put extra information in it? Well, first of all, let's do something I'm pretty sure will fail.
Or extra information that wouldn't break the other parameters?
Yeah. I got to edit this now. Let me go back to normal size. Okay, I'm going to misspell this. I'll call it Namex instead of name. And then I'm going to go send it. And what I get back is unprocessable entity. So it gave me back a 422 error. And apparently that's just the code it's using. There are all these predefined codes, and it's using to say there was a problem. And it even sent back JSON that explains what the problem was. Name is too short. No, that doesn't make any sense. Missing field, it says at the top. Okay? So when you write a program, of course, you have to pay attention to this code that comes back. Because if you get a 422 back, you know you made a programming error. You can't interpret you don't want to look at the result and use it in some other way. So I'm going to change this back to name. And he asked, let's say I put in some other one like foo. And I'll make it be an integer 5. Let's see what that does. It ignored it. So questions like that, you might be able to find the answer in the API, but with the ARC you can just play with it, see what's going on. So it created it, and it sent back in the body of the response, it sent back information about the repo it just created. The full name, the unique ID number, and so on.
Did it
So-
actually make it? Does the RESTful API actually like commit the?
Yeah, well, yeah, let's go look. So if we go up here to GitHub, go back, and how do I get my repos? Okay, so there are my repos somewhere.
So you go to user repos. Yeah, that's repos. Oh, that's. You went to the user repos.
Where do I need to go? Ah. Okay, tell me where I need to go to see my repos.
Copy and paste.
Oh, they're over here. There it is, demo repo just got created. So it's just like I dropped into GitHub and created the repo. All right, let's look at another one. So that was create a new repo. Let's add a file to a repo. So this, it says use a put request, so that's what I'm using. The URL is like repos Le Dubois demo repo contents file 1. And the headers are the same. If we look at the body, the body is carrying a JSON object that has a message, which is the commit message, because we're creating a commit that contains this file. And then there's the content of the file that I just typed at random. So when I run this, it'll actually create a new commit on that repo that contains that file. And the file will be called file1 because I said so up in the, I'm zooming in here. File1 is taken from up here. So let me send that. So I just committed, and if I go back to GitHub, I go into demo repo. There's the commit that contains file1. If I look at file1, oh, it contains this as a test. Okay, so I think there was some encoding I had to do to the string before I actually sent it up. Let me get you first.
I guess this depends on the different APIs, but some have like required fields that you need to push, and some are additional fields that it takes.
Yeah.
in.
Mhm.
Okay.
Yeah. So you just got to read the API to figure out what's going on. Yeah.
Is the URL like path name? Does that translate directly to like a path name in the file structure of the server? Or is
No.
that more like a
Okay, so he's like up here. The path name is Le Dubois / demo repo. Oh, we're not looking at the right thing. It's repos / Le Dubois / demo repo. So let's think about that. / repos is, if you want to think about it, it's the program we're running. Le Dubois is the username for this, the username that I'm using. Demo repo is the name of the repo I'm talking about. So essentially, Le Dubois and demo repo are parameters, but they're in the URL. So they don't correspond to any physical organization. Then there's contents, which it says to put, and then that's the file name, file1. So what the server is doing is it's looking at this URL, and it's pulling out Le Dubois to find out who I am. It's pulling out demo repo to figure out which repo I'm talking about, and it's pulling out file1 to be the name of the new file. Then it's doing its thing. It also has to look at the request body to get the contents of the file. Yeah.
For the contents, it has like it almost looks like an encrypted.
Yeah, I think I had to, it's not encrypted, it's not hashed, it's not for security reasons. It's you can't put arbitrary characters in the body of a JSON. Like what if you want to double quote in your string? You'd have to escape it somehow. It's base 16 encoded, that's what it is. So, and encoding is just a way to make sure that there's no special characters. So it represents everything. Now that doesn't look like base 16 encoding. Anyway, it's some kind of encoding. I'd have to look in the program that created it to remember how I encoded it. Okay? So one other one to look at is delete. So delete, here I'm saying repos/ladyblock/demo repo. I'm asking it to delete the repo. And I send it, and it deletes. It gave me back a 204, no content, which means it's okay, and I'm not sending you any other information. There's nothing in the body of the response you're interested in. The 204 is all. And if we go back now to up here and refresh this page, it's going to tell us what demo repo, because it's been deleted. So that's what web services look like. Now, what you'll be doing is writing creating a word game, a client that plays a word game against other players, against each other. And there'll be a server that mediates the games. The server keeps track of all the ongoing games and decides what the score are and such. And so all your clients will have to communicate via API designed. Actually, some students designed it years ago to make your clients work. So you'll have to learn that API. So
Scrabble,
well, it's Boggle, if you've ever played Boggle. Yep.
So then with this GUI, are we just done with spreadsheet and moving on to new projects then?
Yeah, after PS7, you're done with the spreadsheet.
Thank God.
Now, in the past, so Peter Jensen teaches 3505, but you wouldn't have him in the fall. In the past, he has done an assignment where he has you resurrect your spreadsheet from 3500 and do something with it, sort of in the middle of the next semester. But I don't know if he still does that.
Could you tell him not to?
Yeah. You just pass this class, and you take 3505 from David Johnson, and there's no chance that you'll have to do that. So. Okay. So I've shown you how to play around and debug requests you're making of the API. So you'll be using this a lot to try to make sense of things before you put it into a program, because it's a lot easier to debug here, to figure out what you don't understand here than it is to figure it out somewhere else. So what remains is to see how to do it in a program, and also to see a little bit more about REST. So I'm trying to decide what's more important for now, because the problem is you're not going to see. The problem with this right now is you're not going to see this again until you're not going to use it until PS8, which isn't for a while. So I think I'm going to stay away from programming details right now. This is a different browser here. This is. Any of you do geocaching?
I think we did that 14.
Yeah. This is a geocaching page here. So Les Dubois is my geocaching name. I just used it for my second GitHub account. So go out and find Les Dubois caches if you wish. Okay. Here we are. REST architecture. So I dropped out of Google Slides because I wanted to show you how it actually works from the Advanced REST client. And these slides just contain screenshots of similar kinds of requests. So there's a typical GET request. That's part of the JSON response that comes back. We saw that in the Advanced REST client. There's an example of a POST request, and you can see the body is down here. It's just a JSON object being sent. There's part of the response that comes back. There is a delete request. All right, so I started all this out by saying we were interested in learning about the RESTful architecture. So REST stands for Representational State Transfer. And I don't remember when it became a thing. It was a PhD dissertation that was trying to describe the students' thoughts about the correct way to organize web services. And so he described the principles of what a RESTful architecture are, and argued for why that's how APIs ought to be organized. And he sort of won, because since then, REST is a thing, and most web services tend to be organized that way. So there were older ways of providing web services that had acronyms like SOAP, which is Simple Object Access Protocol, and WSDL, which I don't remember what it was. It's a description language. WSDL was the attempt. You use WSDL to describe web services, sort of the same way an XSD file describes an XML file. So sort of a detailed description of what the request and the responses should look like. And that's fallen out of favor. You don't see them much anymore. REST doesn't mean HTTP, but typically that's how it's done. So RESTful services are consumed via HTTP requests. Typically, there's a handful of, I call these verbs, of types of requests you can make, and 99% of the ones that you see are get, post, delete, and put. And we've seen examples of all that.
That's what they're actually called, though, isn't it? Verbs.
It may be.
Protocol.
Yeah, the official name may be verbs, but I've used it for so long I can't remember where I got it. So.
That's what Wikipedia says.
Okay, Wikipedia says that it's not just my word. Okay, the web was the inspiration for RESTful architecture, just the regular web with web pages and web browsers and web servers. So the student was basically arguing to extend the way we think about the web to the way we think about services. So these are aspects of REST architectures here. So it's based on a client-server organization. So the server holds the information, and the client's just worried about the interface. Let's think of a different architecture. That's not, well, so client-server, that's pretty standard. Imagine you had a server that wanted to, like I use chess.com a lot. And so at any given time, there are thousands of people playing chess games. And it's connecting you with someone somewhere else playing a game of chess. And you make moves in your client, and you send the move you want to make to the server, and it sends that move down to the other client, and the board gets updated. And there's a clock ticking, and there's legal and illegal moves. But all the information about the ongoing game is maintained in the server. Now you can imagine a different architecture that said, I don't want the server to have to be bothered with the current state of the game. Let's store some of the information about the game down in the clients. And so the complete picture of the game isn't in the server or the clients. It's sort of in both places. You have to look at both places. That's a non-RESTful organization, when the clients themselves contain part of the information in the system. In a REST, all the information is in the server. The clients may hold pieces that are duplicates or copies, but they're not participating in representing the information. All right. It says uniform interface here. So a REST server is resource-based. And the way the server sees the data is completely different. It's not necessarily the same way that the client does. So the server is using a database, some sort of database to keep track of things. When we look at pieces, we don't make queries against the database. We don't even know there's a database there if we're a client. We just know how to make requests, and we get back JSON. So we're completely insulated from the database. You saw in those URLs that to do something to a resource, we had to be able to name it. So the URLs tend to be ways of naming resources that you want to operate on. And this last thing, response, contains all the information needed to interpret the response. So that just means that when you get the response back, you don't have to go to a separate document to figure out what the response means. It's all self-contained. REST architectures are stateless. So all the information needed to deal with the request is contained in the request. There are no sessions. So when you go to a website and log in, one way to do that is by starting an HTTP session. And this is saying that REST servers are, connections are stateless. So when we're accessing the GitHub server, how is authentication handled in a stateless manner? The tokens. So it's not like the server is not remembering, this client logged in. The client running at this web address logged in and remembers that piece of information. No, the client just has to possess a token, and as long as you present that token in a request, then the server accepts you for who you are. But the server isn't remembering. Each request is like out of the blue to the server's point of view. It just looks at what's contained in the request and figures out what to do. It doesn't remember anything about past requests and who you were. And the rest of this, it's possible to cache responses. You may be talking to an intermediary. Lots of, of course, you write a PhD dissertation on this. You claim advantages, and that all looks good. It increases performance. It makes the system scalable. It makes the system simple, and so on. And since it's caught on so well, I guess he was right. So that's what's meant by REST. So you don't really have to understand every detail of what a RESTful architecture is to use one. And we'll be relying on that. So here are the 4 verbs we'll use most of all. So there's a GET request, which is typically used for read-only queries. So you just want some information. You don't want to change anything. Give me the list of all the organizations I belong to. Give me all the list of commits in this repo. That's a GET. And the parameters typically go up in the query string. A GET request should be safe, meaning safe means doesn't change anything. And it should be idempotent, meaning if you do the same GET request twice in a row, you should get the same response. A post request is for creating a brand new resource. So you create a new repo, create a new user. That'll typically be a post request. And that's not safe, meaning if you create a new user and then do the exact same thing again, you're not going to get the same result. I mean, you get an error message because the user already exists. And it's not safe because it changes the resource. It's not idempotent because if you do it twice in a row, you get a different answer the second time. Delete is for removing a resource, and put is for modifying a resource. There's no rule that says it has to do that, but the API is typically respected. Yep.
What do you mean by cacheable?
I mean, you can, rather than ask again for the same information, you can just save it locally and use it later. It's savable. All right, so that's a high-level view of REST. Yeah?
Just to clarify something, RESTful, like fully RESTful, is all based off the server and the client just kind of can go in and out?
Well, it's all those things I said. So it's client server. To me, the important thing is client server and it's stateless. And all the information you need for it's stateless, and that you just have to make a request that contains all the information needed. All right, I want to give you a preview. We'll have to come back to this another time, but I want to give you a preview of how you do this from C#, because there are actually some pretty neat aspects of C# that you end up learning about when you do this that you wouldn't know about otherwise. So let's just look at one of these here. So up here I've just defined some constants. So if when you download this code, it won't come with this token defined. And again, I'm going to delete it after class anyway. These fields will be empty here. You have to provide your own information. And there's several demos. So this first thing is a demo of a GET request. So let's see how it works. So in C#, if you want to communicate with a remote client via HTTP, you've got to start by creating an HTTP client. This is a helper method to do that for us. So you can see what it does is it creates an HTTP client object. It sets the base address. I just plugged in that this is all has to do with GitHub. So it sets the base address to that. It sets some default request headers that you saw. So you see here it's setting the accept header to be that, because the API says so. It sets the authorization token to be that. It sets the user agent token to be the result of escaping my email address, and then it returns it. So this method sets up an HTTP client that can be used all through the rest of the program. This here I had to add right before class. It turns out that the default security protocol that GitHub uses has changed since last year. And so the security protocol it uses, it no longer will accept the default security protocol of .NET. They stopped accepting it, so I had to look it up, figure out. I was desperately figuring this out. I found it on Stack Overflow, but anyway. All right, so here's an example of how to issue a GET request. We go to get demo first opens up a client I just showed you, so it creates an HTTP client that's initialized with all the headers that are needed to communicate with GitHub. This thing is copiously commented, so you can look at that later. And here's where we issue the request. We say, client, do a GET call on that URL. So it appends that to the end of the base URL that I gave it when I created the client. It turns out that this method here returns a task. Get async, because this can take a long time. So what it does is it returns a task which is conducting the call. And then sometime in the future when that task finishes, you can pull out the result. So I'm not making use of that fact. I'm immediately asking for the result. But in principle, you could call get async and go do something else while it's being processed, and then come back and get the answer out of it. But I'm just immediately asking for the result, so I might as well not be using the async call. But we will learn how to make good advantage of that.
Can you hook up like events to it? Like so that way instead of there when it's ready, you can come back.
Can you find, yeah, let me see. I'm not sure. I have to figure that out. Okay, so you get back a response. We check to see, was the response successful? So remember the code might be 200 or 204 or whatever. Typically, one that starts with a 2 is a success. So we're just saying, was it a success? And if so, what's coming back is the answer. So the body of the response contained the JSON, right? So what I do is I say, go to the response, get the body content, start a task to read the string, because reading the body may involve more data coming from the server. And I immediately ask for the result of the task. So we block while we're waiting for the result. So now we've got the result. All right, here's where it gets really cool. Those who like Python will like this. The result is a string of text. There's a method called JSON convert that converts JSON back into a C# object or array or int or double or string or whatever. So this start here, JSON convert .deserialize object to result, takes the text that's in the body that we read from the body, turns it into C#. Now, the result may be an int. If the body was an int, the result would be an int. If the body was an object, it'll be some kind of object. If it was an array, we'll get an array of some kind. Or maybe you get a list, I don't remember. But the problem is, what kind of variable can you store it into? And the answer is, you don't know. It depends what it got converted to. So you could store it into a variable of type object, and then start saying, then start using the is keyword to say, is this object an int? If so, do that. Is it a string? If so, do that. C# provides something called dynamic. You can store anything you want into a variable declared of type dynamic. Now, you may be saying, but there's one called var, and you can store everything you want into a variable of type var. But the difference is, var is just a shortcut. If you're too lazy to type the type of the variable, you put var, and the compiler figures out the type for you, but the variable still has a type. You have to use it consistently. Dynamic, you can store anything you want to. You can store an int in it today, you can store a string in it tomorrow, just like Python variables. And then you just start using it. And as long as the way you are using it is consistent with what it really is, it's happy. If you use it in a way that's inconsistent, an exception will be thrown at runtime. So you don't find about the type errors until runtime. So what am I doing here with this thing I got back? I got back I deserialized my body. I've got some unknown C# object in here. Some C# value. What am I doing right here?
Checking every dynamic object.
I'm iterating through it, right? Now, what if what I got back was an int? What would happen when I tried to iterate over it? That's where the exception would be thrown. So in fact, let me do this. Let me do let's do console.writeLine orgs times 2. So I'm going to hope that what I get back is an int, and I'm going to multiply it by 2 and print it out. All right, let's run the program and see what happens. Unhandled exception. Operator star cannot be applied to operands of type newtonsoft.json.link.jarray and int. So I used the data inconsistently with the way it's supposed to be used. So that's no good. Why is it safe to iterate over it? I'm not checking to see if it's a list of any kind or an array. I'm just iterating over it. Why am I doing that? Why am I risking this exception? What do I know that the program doesn't?
You know the result.
I know I'm supposed to get back a list of objects. And so I'm just trusting that it sent me back the right kind of thing. So I don't have to declare this as being, I mean, you saw what the actual type was. It was like some weird JArray type defined in some library. All I have to know is whatever I get back, I'll be able to iterate over it. Okay? But I don't know, the program doesn't know what type of thing is in that list. And so when I iterate over it, I've got to store it in a variable, and I declare that variable of type dynamic. Now, so in the body here, if that object has a login field, I'm golden, and I'll be able to access it. If it doesn't, there'll be a problem. Yeah?
So what if you want to check what type of object that is under your code?
You could. You could do something like this. If org is int, do something.
Does an object do that as well, though? What's the difference between object and dynamic?
Okay? So let me finish this question. So right there, yeah, we figured out, you could test it. You can always test something that way. Well, let's try using object instead of dynamic here. Okay? It's complaining because all it knows is org is an object, and objects don't have a login property. But if you say dynamic, it just takes your word for it. If it turns out not to have a login property, then you get the exception at runtime. Some people like this, some people don't. The advantage of not using dynamic is you find out about all your type incompatibilities when you build the program. But you have to put up with declaring all these types. Then there's a point of view of Python which just says, just use your values consistently and we won't have a problem. But if there is a problem, you don't find out about it till your program runs.
Freaking needed to know about that yesterday. It was like some of my code was in another class.
Mhm.
And I was storing it as an object in the other class, and I was trying to refer to
Yeah.
the method in the other class.
Now, I don't know what happens if I say var here. Yeah. So now the error is saying, yeah, all C# is able to tell from this is that it's getting back an object of some kind.
Wasn't pursuing farm
Oops.
object.
So yeah, var didn't work. So dynamic is just, it just takes your word for it that you plan to use it consistently, that you know something it doesn't. Yeah?
Can you then, like in Python, have an array where the first index is a string, and the second index is a person, the third index is a dictionary, and things like that?
You typically don't see something like that in the APIs, but I think that would. Well, let me take that back. The underlying we don't know what orgs is, but it is some kind of has to be some kind of C# object. So if you can create a C# object that contains a string, an int, a bool, then yes, it could happen. But I don't know if you can create a C#. Probably can't. The best you could do is create a C#. Yeah, you could create an array of objects and put different things in it. So yeah, definitely, you could do that. Yeah.
Can you treat dynamic like a primitive type? Like you can make int arrays and string arrays. Can you make dynamic arrays where you can like?
Yeah, you can create arrays of dynamics. Yeah, you can do stuff like this. You can say dynamic x gets 2, then you can say x equals hello. It just trusts you to know that you know what you're doing.
If you're implementing a generic like class, could you pass dynamic as a?
Now I don't know if you can have it. Yeah, I guess.
Because like I know with like generics, like.
Yeah.
different types.
So I mean, you could throw all the type system out the window and just declare everything dynamic, and or you could just program in Python in the first place. So. Okay, so there's not much more to see here. I iterate through, I print out all the login names, and if I get back something that was not a good response code, then I print out something here. So you won't see this again for a while, because next week we're just dealing with midterm stuff. We'll come back to it and refresh your memory at some point in the future.